Somewhere in the ground, there is a lump of gray rock that knows where north is. Not a machine, not a tool anyone built, a rock. You can dig it out of a hillside, chip off a thin splinter, hang that splinter on a thread, and let it settle. And it turns, slowly, deliberately, until it lies along one invisible line, and then it stops. Push it away with your finger, and it swings straight back, every single time. The same line. Nobody put that information into the stone. It came out of the earth like that. The ancient Greeks knew about it, the ancient Chinese knew about it, and for hundreds of years nobody used it to find their way anywhere. They used it to tell fortunes. The story of how a fortune-telling stone became the reason ships could cross oceans runs straight through the middle of the planet, down to a sea of liquid metal 3,000 kilometers beneath your feet. So start with the rock itself. It is called lodestone, and lode is an Old English word meaning a way, or a course, or a journey, the leading stone. Chemically, it is nothing exotic at all. It is magnetite, an ordinary oxide of iron, one of the commonest minerals on Earth. There is magnetite in beach sand. There is magnetite in the dust on your street. And almost all of it is not magnetic in the slightest, which is the first strange thing here. Magnetite is full of tiny magnetic patches, all pointing in random directions, pulling against one another, canceling each other out to nothing. To wake the rock up, something has to line them all up at once. And the best guess we have is lightning. A strike carries an enormous surge of current, and a current makes a magnetic field. So for one violent instant, the ground around that strike sits inside a field strong enough to turn every one of those patches the same way. The lightning ends. The alignment stays. Which is why lodestone is only ever found at or very near the surface. It is not really a mineral. It is a scar. A lump of ordinary rock that got hit by the sky and kept the memory of it. Now the people who did the most with this were the Chinese, and they were not sailors when they started. They were diviners. Texts nearly 2,000 years old describe an object called the Sinan, the South Pointer, and it is a spoon, a small spoon carved out of solid lodestone, with a heavy rounded bowl and one long thin handle, sitting on a polished bronze plate. You spin it. It wobbles, slows, and settles, and the handle comes to rest pointing south. Around the rim of the plate are the directions and the signs of the calendar. Because this was not a navigation instrument. This was equipment for reading the world. Which way should the door of this house face? Where exactly should this grave go? Is today a good day to begin? The spoon was there to settle those questions, the way a diviner's tools always had. And we should be honest here. No original spoon has ever been dug up. What we have are the written descriptions, and the reconstructions built from them, and those work, but only just. Because a lodestone spoon is actually a terrible compass. The pull of the stone is weak. The spoon itself is heavy. It drags on the plate, and friction beats magnetism nearly every time. To turn this into something a ship could trust, you have to make the magnet almost weightless. And here is the actual invention. Not the stone, the needle. Somebody worked out that magnetism can be handed on. Take a plain iron needle, lay it against the lodestone, and stroke it along the surface, the same direction, over and over. Nothing visible happens. The needle looks exactly the same as before, but inside it, everything has changed. Iron is made of those same tiny patches, little regions where the atoms are already magnetized together. In a fresh needle, they point every which way, so the needle as a whole is nothing. Hold it inside the lodestone's field, and the patches that already agree with that field quietly grow, and the ones that disagree shrink, and the stubborn ones simply swing round. Stroke by stroke, the argument inside the metal is settled, and the whole needle now points one way. The lodestone has not lost a thing. It has made a copy of itself in a sliver of iron weighing less than a gram. And now you can float it, on a splinter of wood in a bowl of water, or hang it from a single silk thread, no friction worth mentioning. And a needle that weighs almost nothing can feel a field that is almost nothing. In the year 1088, a Chinese official called Shen Kuo wrote all of this down. He describes the stroking. He compares 4 ways of mounting the needle and picks the silk thread as the best. And then he notices something that should have been impossible to notice. The needle does not point exactly south. It sits very slightly off. He is the first person in the world known to have recorded that magnetic north and true north are 2 different places. Europe would not write that down for 4 more centuries. 30 years after Shen Kuo, another writer describes ships out of Canton using the needle at sea, and he says exactly when they use it. When it is dark. When it is cloudy. By around the year 1190, the same trick appears in European writing. and within a lifetime it is standard kit on a Mediterranean ship. But nobody could say why it worked. For centuries, the guesses were wild. Maybe the needle was reaching for the pole star. Maybe there were magnetic islands in the north tugging at the iron in every ship. The real answer took until 1600, when an English physician, William Gilbert, carved a whole sphere out of lodestone and walked a tiny compass across its surface. The little needle behaved exactly the way a ship's compass behaves on Earth. Dipping, swinging, reversing at the poles. And Gilbert drew the conclusion. The needle is not pointing at anything in the sky. The Earth itself is the magnet, the whole planet. And once you ask why the planet is a magnet, the compass stops being a sailing instrument and becomes something much stranger. Because the answer is in the core. Go down through the crust, down through the mantle, solid rock all the way, and about 3,000 kilometers down, the rock simply ends, and you reach an ocean of liquid iron. It is thousands of degrees hot. It is under crushing pressure, and it is moving. Heat from below drives it upward in slow columns. The spin of the planet twists those columns, and the whole enormous mass churns. Now, molten iron is a metal, and moving metal carries electric current, and electric current makes a magnetic field, and that field pushes back on the moving metal and keeps the current flowing. The thing feeds itself. Geologists call it the geodynamo, and it has been running, with interruptions, for billions of years. That field loops out of the planet, through the ocean, through your kitchen, through the air around your head, and back in at the other end, and a floating needle simply falls into line with it. So think about what a compass really is. It is not a pointer at the North Pole. It is an instrument reading the movement of molten metal 3,000 kilometers under the seafloor. Nobody will ever go there. No drill will ever reach it. No light has ever touched it. And yet you can hold the readout in the palm of your hand. You can even watch it change. Magnetic north is not fixed. It wanders, tens of kilometers a year, because the currents down there shift. And every so often, over thousands of years, the whole field weakens, tangles, and comes back the other way round. The last time it flipped was about 780,000 years ago. Now for the part that changed the world. Think about what finding your way at sea actually meant before any of this. You had exactly one instrument, the sky. The sun told you east and west. The pole star told you north, and that was the entire system, which means the moment cloud rolled in, you were blind. Not slowed down, blind. No sun, no stars, no direction, and nothing outside the boat to tell you which way you were drifting. So sailors stayed where they could see land. They ran from headland to headland, counting off known shapes along the coast, and they sailed by the season. The Romans had a name for the winter sea, Mare Clausum, the closed sea. From roughly November to March, when the sky stayed gray for days at a time, shipping across the Mediterranean largely stopped. Grain, letters, armies, news, all of it sat in port waiting for clear weather. For half the year, the sea was a wall. The needle takes the sky out of the equation. It does not care about cloud. It does not care about night or fog, or how long since you last saw a coastline. Point the ship at a mark on the card and hold it there for a week. Within a couple of generations, Mediterranean ships are sailing through the winter, and historians reckon a merchant ship could now make 2 round trips a year, where before it managed only 1. The sea, in effect, had doubled, and a compass gives you something else: repeatable bearings. If every ship measures the same angles, then the same route can be written down and drawn, which is exactly when the sea chart appears. Coastlines traced from real bearings, crossed by a web of straight lines radiating out from compass roses. Navigation stops being memory and starts being a document. And then comes the real leap. To cross an ocean, you have to hold one heading for weeks with nothing at all to look at. No coast, no landmarks, nothing. And that is a thing you can only do if something in the boat keeps telling you where you are aimed, whatever the sky happens to be doing. So the ships go down the coast of Africa, then out west into the open Atlantic, then all the way around the world. And every one of those crossings rests on a splinter of iron, stroked against a rock that was struck by lightning, floating in a cup of water, quietly obeying a current of molten metal 3,000 kilometers down. We crossed the world because a stone remembered which way was north.